Hello, today we're going to look at domain and range of a graph. So our domain of a graph are our x values. So when we ask for the domain, we're looking to see the limitations of x. Our range, on the other hand, is our y values. So we're looking along that y-axis to find the range of our graph. Our x values are our input. It's what we plug into an equation. And we're going to be looking at how to do this with an equation next class. And our y values are our output values. What do we get as an answer when we plug x into our equation? Here's our first graph. Now we want to know what both the domain and the range is. So when we look at our domain, we're looking at our graph from left to right. What is the smallest number? What is the smallest x value on the left? And what is the greatest x value on the right? Now, when we're setting this up, we know we're dealing with x because x is our domain. So we put our x in between, and we're going to put less than equal to on either side because we have closed dots, the furthest to the left and the furthest to the right. If one of those dots was open, then it would simply be a less than. But because we look at our graph and we see closed dots on our furthest point to the left and our furthest point to the right, we know that that's going to both be x is less than or equal to. Now what this says so far is x is between. So we're going to go ahead and take a look and see how far it is to the left. And as you can see, counting along there, we know that it goes as the farthest left of x of -6. So we're going to go ahead and put a -6 on the left side because that's our left boundary. We're going to go ahead and take a look at the right. And as you can see, that also goes to a number, and this number is +6. So we're going to have our 6 to the right. So this tells me that the entire function that you're looking at on this graph falls between the x values of -6 and 6. So I know that a 7 would get me an equation with no solution because it's outside of my function. We're also going to make sure that as the domain, we're always looking from left to right. Always looking from left to right because domain is our x values and that is our x-axis. Now our range, on the other hand, we're going to go ahead and take a look at, and range is our y-axis. So we're not dealing with x's anymore, we're dealing with y's, and we're looking from bottom to top. So now we're going to take a look at our y values. So it's not an x anymore, it's a y because range is y. And I see that the lowest point is a closed dot and the highest point's a closed dot. So we're going to have less than equal to's for those again. Once again, if one of those was an open circle, it would simply be less than, not less than equal to. So now we're going to go ahead and look at the bottommost value. And as you can see, this is actually on the x-axis, and that has a y value of 0. So we're going to go ahead and put our 0 to the left. And we look for our highest point, and our highest point there, as you can see, is a +6. It goes up to 6 on the y-axis. So all of our values of y, or our range, is between 0 and 6. Anything outside of that does not include our function. So if I look at a -1, you can tell that -1 does not have part of the graph at that point. So for this graph, our domain, all of our x values is between -6 and 6. And our range, all of our y values are between 0 and +6. So remember, bottom to top for range, left to right for domain. Let's go ahead and take a look at this second example. As you can tell, this is a line segment, and there's a couple things that we want to notice. First of all, we see closed dots. So we know that all of these are going to be less than equal to's. So we're going to go ahead and start with our domain. So once again, we're looking from left to right. So we're looking from left to right. So we're going to put our x in the middle, less than equal to's on either side, and I can see that my left is at -4 and my right is at 2. So for my domain for this function, for this graph, all of my values of x are between -4 and 2. Now we're going to go ahead and take a look at range. Remember, our range is from bottom to top, the lowest point to the highest point. So here's my lowest point at -2, and my highest point is at positive 4. Once again, we're dealing with range, so we're going to be careful to talk about our y values. So our range is y's are between negative 2 and positive 4. One last one, and this one's a little different, and the reason why is you see arrows. So as we're looking for our domain, we are going to go ahead and look from left to right. I see going to the left, I actually have an arrow continuing forever. I look to the right, I have an arrow continuing forever. So when we have arrows going both left and right, we know that our domain is going to be all real numbers. The most common place you'll see this is a regular line with arrows on both sides. That has a domain of all real numbers because there's an arrow going to the left and an arrow going to the right. We're going to go ahead and look at our range. Now, our range in this case, remember, we're looking from bottom to top. Now, if we had an arrow going down and an arrow going up, it would be all real numbers. But I see I actually have a bottom point. I have a bottom point here, and that's at positive 2. Now, I can tell that it's going to continue forever going up. So the way that I say this is I say that my y values are all going to be greater than or equal to this point. So my y values are going to be greater than or equal to positive 2. Okay, if it was a parabola going down, it would be less than or equal to negative 2. So as we're looking for domain and range from a graph, what we have to remember is our domain is our x values, and we're going from left to right with our x's, and our range is our y values, and we're going from bottom to top with our y values.